Emerald Hill skies. My name is Doug, and we're glad to have you here tonight.
NGC 2474.
We've just zoomed in on NGC 2474. If you've got your data with you, let's see if we can. Let's see, where are. Why do we not have the mount controls there? Where are the mount controls? What's happened to the mount controls? Scope controls. Anyway, just trying to get my bearings. Just downloaded a new version of SharpCap, and there is no plate solving available. Wonder why that is. Well, let's get you over there to the screen. Maybe you can help us figure this out. Anyway, welcome everybody. I saw in here that Stu, you were the first on tonight. Let me check and make sure you got audio here. Yeah. Stu, good to have you on board. Ray, I'm sorry about the clouds, but that enables you to be here. Dennis, good to have you aboard. Okay, let's figure this out. Now, what's happened to my mount? I guess we don't have it connected yet, but in this version, it's a brand new version of SharpCap. Where did we put the mount controls? See, there's capture profiles, capture format and area, camera controls, image controls, thermal, miscellaneous controls, pre-processing. The mount controls are gone. What? Anybody know about this? Let's see. Let's go under SharpCap settings. And let's look up, been forever since I did this, hardware, mount. Select hardware, iOptron. Okay, that did it. You know, I think I know what that probably was. Now we'll try to plate solve. I think I know what that was. When I started the setup tonight, the rig.
Viewing NGC 2474.
I noticed that the iOptron Commander app was completely gone. I don't know why, but it just disappeared totally. So maybe it had an expiration date for the version I was using. And sure enough, I was on version 8. So when I went to the iOptron site, sure enough, it had a version 9. So I downloaded it, and I bet that's why SharpCap didn't recognize it, because the version number had changed. Okay, so now let's think about what do we have here. We're looking at a NGC 2474. This is a, we're trying to get a globular cluster and a NGC 2474. Is that right? NGC 2474.
The telescope is slewing. Viewing NGC 2474.
Yes. Okay, so that's
viewing NGC 2474.
Where did my brief go? Let's see. Trying to figure out. Tiffany, good to have you here, Tiffany. Where did the brief note go so I can tell the object numbers? brief, no brief, it's supposed to be there. I bet it's in here. No, that's not it. Note brief. Oh, we're just going to have to expand this and look for it. Ah, there it is. It's over there. Let's drag it over here. Right there. Okay, so this is object 186. 186 in the Cosmic Challenge list. You guys that have been with us before, if you're just tuning in for the first time, this might be new stuff for you, but we use this book. We're on this book lately, Cosmic Challenge. 186, NGC 2474 and NGC 2475. It's apparently a galaxy pair. So let's prep for imaging only. Let's put in the name here. This will be NGC 2474. And can I use this sequence called prep for imaging only? I think that one just starts right into live stacking. That's the one we wanted. Missed you as well, Tiff. We've had some pretty cloudy nights here, but good to be back tonight. John, good to have you aboard from Magdalena, New Mexico. All right, maybe you're noticing that, there we go. So let's do a reset of this display histogram and then reset this and the color balance. And then let's pull back here and look for this galaxy pair. Boy, it's a beautiful black sky tonight, isn't it? Moonless. I did discover a shortcut key for deep sky image annotation. I think it's Control-Shift. Oh, now I've forgotten it. What was it? Is it Control-Shift-A? Yep, that's it. So they're supposed to be 2474. So let's zoom in at 100%. Wow, that's a tiny galaxy, isn't it? Now I wonder if I can just click that off. Where's 2475, I wonder? Maybe we have to zoom in more closely. 2474. You know, we don't even have a, so let's bring up an atlas view of this. Atlas view should be right there. Must be off screen. Here's the tool I'm using, but I can't get it to go into night vision tonight. So why can I not see this atlas? This is this new Sky Tools 4, and I'm liking it pretty well, but it's kind of unsettling that it won't go into atlas mode. Might have to call up. This won't cooperate. Might have to call up Stellarium, huh? It's probably off screen somewhere. This thing is cantankerous about opening up its images off screen. It's kind of weird. I'm gonna have to figure out how to make it. Boy, it is just refusing to open it. Tell you what, everybody block your eyes for a second. I'm going to bring this up here for just a minute. I know it's going to blind you. It's very bright, isn't it? Oh my goodness, that's too bright. Now, I think I'm going to just click here and say Interactive Atlas. See if it'll bring it up on that screen. There it is. Okay, so that's what we needed. Then we'll bring this back over here like this. Now, so there's 2474 and 2475. So they're right there in the middle. So it's these two. 2474 and 2475. Now, that's too bright, isn't it? I'm going to just get it down off the screen because I don't want that to be blinding you guys. I'll have to figure out how to do the night vision mode. It's just not working now. Anyway, so there's 2474 and 2475. Boy, very little being said about them here. Just 81,000 light years wide, 260 million light years away, elliptical galaxies, and both are in this constellation. Is that Lynx? L-Y-N. Okay, so to do to log, then we go create a log entry. Let's just do like this and say, sure enough, February 2nd. That's all correct. Create log entry. Boy, those are all too bright as well, aren't they? We're going to say tiny little pair of ellipticals.
Telescope position synchronized.
Oh, this is what happens. See, like a pair of eyeballs. So I wonder if I pull this down here, get that out of our way. Let me do this one more time and pull that down here. So that won't be on our way either. Okay, I think we're set now. So that's 2174 and 2175 as well. Just do a quick log entry on it. All right, so now we'll stop live stacking. Good to have you back, Larry. The new version of SharpCap is 4.1. By the way, the next object is going to be 2535. 2535. The new version of SharpCap. Let's get this mount slewing that way. Slew scope to 25.
The telescope is slewing.
Is 4.1.11.757. It's a beta 4.1.11.
Viewing NGC 2535.
757. And man, it threw me for a looper, Ray, when I first got on because of this problem with the iOptron mount. You know what they always say, how could anything possibly go wrong, right?
NGC 2535.
154 is the next object. 154 is ARP-82, a galaxy pair, 2535 and 2536. Constellation Cancer of the Crab may not be much to look at. You want to use a yes. Okay. But it holds some fascinating objects within its emaciated body. Case in point, ARP-82, the 82nd entry in Halton ARP's catalog of interacting galaxies. Made up of NGC 2535 and NGC 2536, ARP-82 is a strange pair that seems to be experiencing a galactic version of arrested development. Let's go with this. And there we go. That's all we needed. As galaxies formed in the early universe, theory says that massive amounts of nebulosity came together in quick succession, triggering vast expanses of rapid star formation. Then as each galaxy aged, the rate of star formation slowed. Yeah, I kind of do myself in, Ray. I see you're saying here you'll have to get the newer version. I always upgrade these right before live stream just because I want the latest and greatest. But it does sometimes throw us for a loop here. Thank you guys for your courage. When we use the latest and greatest, sometimes it's bleeding edge stuff, isn't it? Not so with NGC 2535 and NGC 2536, however. These galaxies did not create their stars early in their existence. Instead, based on observation, it looks like star formation was triggered much later. New stars suddenly began to pop into existence. Today we see NGC 2535, the larger galaxy, connected by a bridge of material to NGC 2536. Let's go into 200% here. Right there they are. So here's one galaxy. Let's use our new keystroke. Control-Shift-A. Let's go back out to auto and go Control-Shift-A. Oh, they're not quite on target, huh? We'll have to do this thing where they, but this will give you a chance to see how quickly it solves. Okay, ready? Everybody time this. Ready, set, go. 1001, it's done. That's so fast. SharpCap's new Sharp Solve is just unbelievable. It used to take probably, what, 12 or 15 seconds. Forever. Now it's just instant. Anyway, so now we can go Control-Shift-A and it'll put those right on top. So there's 2536. So now let's zoom in to, say, 200%. There we go. 2535 is on the left and 2536 is there. So this arm of material is cutting across a long tail of interstellar material sweeps away from NGC 2535 directly opposite 2536. The larger galaxy is 2535 and it's connected by a bridge of material to 2536. So a second longer tail sweeps away from NGC 25. Oh, I see. So here's the longer trail. Let's zoom in a little more and let's bring up our mids a little bit to make that pop a little more. Here's that arm of material that's sweeping away from 2536. And here's this arm of stellar material connecting the two. And there's a lot of star formation going on between them. We all learn together that way, right? I don't know how Robin got the plate solve to work so fast, but wow, I know, Dennis, it's crazy, isn't it? Robin is a master with EAA. Amen, Ray. So then, oh my goodness, these are supposedly greater than 2 billion years old. And then he tells how to find them. He says 2535, the one on the left, appears slightly oval and oriented. Its weak concentration only hints at a centralized core, although photos show a sharp nucleus surrounded by an active ring of star formation. Oh, and his 10-inch, he says no hint of structure. And the 18-inch offered little help beyond brightening up the galaxies. Well, I'll tell you what, guys. After just 5 minutes of integration, we can see quite a bit of structure here. These arms look a little bit like whirligig propellers, don't they? All right, so I'm going to do our, see, a log entry is M. We decided that might stand for Mark. An arm of interstellar material is connecting 2535 with 20.
Telescope position synchronized.
2536. Another arm shoots opposite of 2536. We can see two bright stars. See, we can see a bright core on 2535 and another star forming in the outer ring. Almost gives it the appearance that it has two cores, doesn't it? Almost looks like a second core. Dennis says, sure hope this doesn't give me aperture envy. Tiffany says, really nice objects. Woohoo! Ray says, power of RASA. You know, that's right, because this is from the Monster Challenge for 18-inch scopes. So you're right, the 11-inch RASA is kind of compensating for the smaller aperture compared to the 18-inch, isn't it? See, NGC 2535. Okay. Well, I think if nothing else, this helps us understand. We're at 350% of zoom into our digital zoom, but this helps us understand how an 11-inch scope can do somewhat approximate what an 18-inch scope does as long as we're using EAA. All right, so let's get on to our next object. So that was 7 minutes. That's what we try to stick to, isn't it? No more than 7 minutes. All right, so our next object is NGC 1924. 1924. And let's slew over there.
The telescope is slewing.
Boy, it's a beautiful view of the sky tonight. I know that in that view with our night vision camera, the sky looks brighter, but that's just from the light dome of the city light pollution. There go the weights are coming up now. Weights are west, and the telescope is east. So we're past the meridian.
Viewing NGC 1924.
Take a look at that sky. Is that not beautiful? Wow. It's just so dark. It's because the moon is just at 49%, and I don't even think it's risen yet anyway. I don't think it rises till like 1 a.m. So we're looking at inky black skies, and it's just the light pollution there of Louisville. So this is NGC 1924. It's object number 118 in the Cosmic
Viewing
Challenge.
NGC 1924.
118. You've heard of the Andromeda Galaxy and the Orion Nebula, but what about the Orion Galaxy? Probably not, but would you believe the new general catalog lists 21 galaxies in Orion? In the index catalog, another 9. That's a pretty respectable tally. Of those 30 Orion galaxies, I find our next challenge particularly intriguing because it lies so close to everyone's favorite winter deep sky object, M42. Yet, I'm sure that very few observers have ever seen it. NGC 1924. NGC 1924, a barred spiral galaxy was, let's get this display histogram reset. And color balance again. Positioning that dark slider right at the top of that crest. And then let's zoom in. You know, this zoom is pretty handy here. Let's just jump right into 200%. It's a small galaxy, isn't it? But we've got quite a lot of confetti on the screen so far, quite a lot of grain. We'll back off the mids until we get some more integration of exposures. Once again, these are, if you're new to the channel, these are 20-second exposures at a gain of 100 on this ASI2600MC Pro color Astrocam out there in that Pier-Tech 2 observatory. On top that adjustable height Pier-Tech mount. And this is a RASA 11 on an iOptron CEM70G mount. Okay, back to the screen. NGC 1924 is a barred spiral galaxy, and it was discovered in 1785 by William Herschel. Tiffany, you are so kind to encourage. Undoubtedly on an evening when he too was admiring Orion Nebula. And why not? After all, M42 lies less than 2 degrees to the east. That's pretty good company to keep, but at the same time, it can also be a curse, since the Orion Nebula can be fairly distracting. He tells you how to find it. He says, when summarizing the appearance of NGC 1924 for his new general catalog, the NGC catalog, John Dreyer described it as very faint, pretty large, irregularly round with stars nearby. He says his 8-inch barely shows as a faint oval disk, accentuated by a stellar nucleus. I think we're just starting to see the bar now after 2 minutes. It lies between two 8th magnitude stars set amidst a sparkling field of fainter stardust. Larger apertures bring out additional subtle details. Through my 18-inch, the galaxy reveals a brighter outer edge and a star-like central core, closely mimicking the look of a planetary nebula. Add in the spectacular surroundings and how they add a faux 3D effect, and the beauty of this little treasure really comes through. It's a challenge that you are sure to return to time and again as you further explore its more affluent neighbor, M42. Now let's bump up these mids a little more and try to milk a little more out of those rings and stuff. Still a lot of, that's just 3 minutes. But I think we're already starting to see the bar. Seems like it's going to go this direction, isn't it? Brand new galaxy. Okay, so we're going to go down here. I keep doing that. I keep clicking on the note brief. And create log entry. There we go. After around 2 minutes, we could just start to make out the bar. We could the bright core, almost like a star. Not a ton of structure, just an oval glow. That's exactly what it is, oval glow. Hats off to Herschel for finding this live in his 18-inch. What a guy, right? How did he find all these? Wonder what year he discovered this. 1785. In 1785. That's so hard to believe, isn't it? Think about it. 1785. Wow, that's like less than a decade after we had established the United States. He's already got his telescope working. I mean, he probably didn't have fancy clock drive or anything. Just crazy, isn't it? Papa Tech, good to have you aboard from Florida. All right, there's 5 minutes and 40 seconds. I think we're going to call it. Let's go to ACO 426. ACO 426. Now this ACO abbreviation.
The telescope is slewing.
This ACO abbreviation stands for Abell. This is object number 151 in a cosmic challenge.
Viewing ACO 426.
ACO. Stands for Abell. Abell. I think I'll put in the word Abell here. Abell 426. Looks like the mount has settled, hasn't it? Oh, no, it hadn't. We'll have to be sure we wait long enough. I was almost ready to jump the gun.
Viewing ACO 426.
Okay. Ever since I got my first good telescope in 1971, says Phil Harrington, an 8-inch reflector, I've been fascinated with the Perseus galaxy cluster. One reason I'm so fond of this collection of more than 500 galaxies is that the cluster grows as the telescope aperture increases. Small backyard scopes will show the two big kids, NGC 1272 and 1275, but even the largest amateur instruments fail to show all of the little guys. Also known as the Abell Galaxy Cluster 426, the Perseus Galaxy Cluster lies close enough to the plane of the Milky Way that the surrounding field is strewn with nearby stardust, which creates a very pretty overall effect. There are plenty of hidden treasures scattered throughout the cluster's full 190 arc minute expanse. How many can you pick out in your telescope? At about 230 million light years away, the Perseus galaxy metropolis is easy to find. Tells you how to find it. Boy, there's not a lot visible there, is there? Let's reset this large histogram and then back off the color a little bit. Back off the mids. And this altitude is about 46 degrees. Now a few of them are just starting to come into view, but they're not really standing out, are they? So we'll go Control-Shift-A, and you know what we ought to do first? We ought to do one more plate solve. And that's how fast it is. Robin Glover, wherever you are, thank you. Control-Shift-A. Oh my goodness, look at all those galaxies. Okay, so this is IC 0309. IC0308, NGC 1250, IC0310, NGC 1260. There's NGC 1257. That says it's a double star. There's NGC 1265, IC0312, NGC 126. Maybe that's 1264. The center is 1268. Boy, they just keep going, don't they? Now I wonder if we zoom in some more. Just wondered. Yeah, see now it's highlighting more because we're zoomed in tighter. Let's get rid of this for a second and start to look at them. They're very subtle, aren't they? Like little blobs. And every one of those would have, you guys were saying that those all have like millions of stars each, right? Wow. Looks like something like a Hubble Deep Field again, doesn't it? Abell 426. Wow. Ray says, yes, millions and millions, maybe even more. We zoomed in on the middle of this star field, and there were dozens of galaxies visible. By the sounds of Harrington's description, he was implying that 10-inch scopes usually only see 2 galaxies, but with EAA we see tons. Every one of these fuzzy little blobs. Here's one that's gradually turning into a spiral. So if you just count in this one little spot, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. They just go on. 21, 22, 23. Let's bring up the, whoop. They just keep going on and on. It's amazing. Looks like many of these are 15th magnitude. It's a rich star field anyway, isn't it? What a rich star field. Dozens of faint blobs and some spirals. Tiffany says, really impressive. This is the nicest spot right here. So this is the Perseus cluster. At about 230 million light years away, the Perseus galaxy metropolis is easy to find. When we gaze upon that small blemish, we're seeing a seething system in uproar, a galaxy that is emitting tremendous amounts of X radiation. So that's 1275. Where's 1275? 1275. 1272. Oh, here it is. Jeez. It looks like it's right there. So everybody remember where that one is. We'll take off the deep sky image annotation right here. Right there. 1275. He says it's an X radiation emitter. The full story behind 1275 was first unveiled in 1943 when Carl Seifert included it in his list of galaxies with an active nuclei. NGC 1275 is also included in the 3C87 in the third Cambridge catalog of quasars and radio sources published in 1959. And not just any radio source, mind you, but the second strongest in the entire sky. Only Centaurus A, NGC 5128, is stronger. The second strongest radio source in the sky. Studies now reveal that filamentary jets of material are erupting from the core of it and discharging into space at greater than 5.3 million miles per hour. Hubble images reveal what the fuss is all about. We're not looking at one galaxy when we view NGC 1275. Rather, we're looking at two separate galaxies that are intimately embraced by gravity. Photographs clearly show the disrupted disk of a dust-laden spiral cutting through a large elliptical at speeds approaching 7 million miles per hour. In this process, gravitational tidal forces distort each galaxy, compressing huge clouds of interstellar matter and triggering new star formation. Wow. Look at that. You don't suppose that's the second galaxy, do you? See that little splotch right there beside it? Let's go look at it. Look at the Hubble view. So it's 1275. NGC 1275. Brace yourself. Could be bright. Well, it's hard to say, isn't it? Man, what a mess of material. Look at that. Here's that star we're seeing out there beside it. So we're going to assume that's a star, right? That's not the other galaxy. Although it might be, huh? What do you guys think? Here's the galaxy. Here's a galaxy. Where's the one it's cutting through? Is it all just right here in the core? There's a little glow right here. There's a glow right here, and then there's another circle glow right here. So I bet that's all happening right in the core, don't you guys think? So we're seeing that star. I think. We could be seeing any one of these. I mean, there's a bright star too. That's interesting. Look at this galaxy, the way it has a kind of a polarity of, it has like a field and then a field this way. That's cool, isn't it? We need to get us a Hubble, gang. Okay, let's go back to the live view again. So here's a live view, and this is 1275, the second strongest radio emitter in the entire sky, the entire radio universe. Yeah, I think that's that star that was in the Hubble field. But you can see that it's sure chewing up a lot here. It's really cool, huh? All right, that's 13 minutes. We spent a little bit longer on this one, but it is pretty cool, isn't it? All right, the next stop is NGC 604. Looks like it's only at 20 degrees altitude. So let's slew there quickly.
The telescope is slewing.
And it's over in the light dome there.
Viewing NGC 604.
604. GC 604. I don't really like that. See, it already took it away from us.
Viewing NGC 604.
Oh, I see. It didn't take it away. It just it moved it in the stack, and I had lost it for a second. This SkyTools 4 keeps automatically sorting, and I can't figure out how to turn that off. And whenever it does that, the object moves around in the list, but fortunately the highlight stays the same. So that's what I need to learn to look for, is the highlight. Chris, good to have you on board. Euclid. The stuff I was reading? No, it's from the book Cosmic Challenge by Phil Harrington, if that was your question. Good to have you aboard, Chris. There's that light dome. Wow, you think we're into the trees there? Let's sort this as well. I know why. It's because of the light dome. NGC 604. This is a little bit larger object, isn't it? Can you see the trees starting to sneak in here? So this object's not going to be long for this world, but look, it's a little bit larger, isn't it? Oh, that's M33 over there. NGC 604 is here in the middle, and it's a nebula in a galaxy. So right here is where we're looking. Let's get rid of the deep sky image annotation and zoom in here. Boy, it's fairly bright, isn't it? How intriguing. Look how M33 is right here, and this nebula is here off the edge. This is object number 67. Yep, right off the triangulum. You're exactly right, Dennis. Object number 67. NGC 604. The spiral galaxy M33 in Triangulum is one of those unusual targets that can actually be more difficult to see through larger telescopes than through smaller ones because of its huge apparent size. Although it was more than 4 decades ago now, I can still recall my own frustration at trying to find its elusive glow through my first telescope, a long-gone 4-inch Newtonian reflector. Yet today I see it routinely through binoculars. It may come as a surprise to find out that a few of M33's own deep sky objects can be found in 3 to 5 inch telescopes as well as through giant binoculars. NGC 604 is a huge hydrogen 2 region within one of M33's spiral arms. Its small glow lies about 11 arc minutes northeast of the galaxy's central nucleus. William Herschel was first to lay eyes on this distant cloud of glowing hydrogen gas when he noticed it on September 11, 1784. He subsequently listed it as H3-150, his shorthand way of cataloging it as the 150th entry in his compilation of very faint nebulae. Herschel and others went on to catalog many other hydrogen 2 regions and star clouds. It only spans 1.5 arc minutes, but it shines in a magnitude of 11.5. While that may sound unimpressive at first, consider what we're viewing. Edge to edge, NGC 604 actually extends 1,500 light years. So that's this little object right here. Is 1,500 light years wide. We're at 240% there, above our optical zoom. What a rare looking thing, huh? So this object, NGC 604, is 1,500 light years wide, but M42 is just 30 light years wide. It's just that it's so much closer. Man. If we put NGC 604, this object, at the same distance from us as M42, the nebula would cover 50% of the sky. Wow. That's half of the night sky would be just this one nebula. Imagine that sight. We would see billowing clouds of ionized hydrogen gas entangled like little tendrils of an octopus and enveloping more than 200 recently formed stars. Each of those brilliant stars exceeds our own sun's mass by some 15 to 60 times. And there are many more stars to come from NGC 604. One estimate claims that there is enough interstellar material to create tens of thousands of interstellar individual skies. Wow. Can we see any stars in it? He says there are 200 individual stars in the clouds cluster. Let's try to zoom in a little bit more. See if we can make out any individual stars. We're at 400% now. Wonder if that's a star right there. Let's make the background just a little bit darker. And let's bring the mids up just a little bit more. Tough to say, isn't it? Hard to know if that is. Let's go ahead and do the observation, the log. This beautifully bright have to wait until it refreshes. This beautifully bright little nebula contains tens of thousands of stars, or at least enough material to make them. What an amazing thought, that if it were placed at a distance equal to M42, it would take up 50 degrees of the night sky. Whoa. At 8 minutes, we could just start to see a green patch above the core and some structure extending out from the nucleus. Get a load of the structure. Here must be the nucleus, right? Or is that green thing the nucleus? And in these material, wait, this wouldn't have a nucleus, would it? It's a nebula. So there's some green here, which must be like a star-forming region. And then there's some red and yellowish. Let's go look at this in Hubble view. So this is NGC 604. NGC 604. Wow. It's cool, isn't it? Wow. Fun. So this is probably, I don't know, that bright spot. Let's go back to what we were looking at. This bright spot, I don't know. This bright spot here, and then kind of an arm. Looks almost like two antennae. One of those arms must be here, and the other must be here. Yeah. This is the two antennae we're seeing. And that black hollowed out space bring up the white levels a bit. You mean like this? Or you mean the mids? Maybe you meant this luminance thing over here to the right? So this slider, the white level slider, You mean slide it over to the left? Like that? Seems like that cuts it off. Sure is a fascinating object, isn't it? Let's go back to the Hubble view one more time. So these are our two antennae, and that would mean that this part down here is this area, and in that area is this part right here. We're seeing a lot more green in this patch here. And then this is this antennae kind of that sticks up this way. Seeing a lot of this material out here opposite the two antennae. A lot of this material we're seeing. I mean, you stop and think about this is a space telescope up in orbit that costs billions of dollars. This is actually not a bad view for an 11-inch telescope, huh? And in the outskirts of Louisville, Kentucky. It's not bad, gang. Looks like a scribble, Tiffany says. I like it. I'm going to add Tiffany's description here. Tiffany observed that it looked like a scribble. Haha. Ray thought it looked more like the Crab Nebula. I can see that, Ray. Tiffany agrees too. What an interesting object. And this is 604. So let's remember this, gang. NGC 604 in Triangulum. And this is a live view you're seeing here. All right, let's head out. And let's head to maybe Leo 1. Let's go to Leo 1.
The telescope is slewing.
I've really been enjoying trying to get to learn SkyTools 4 visual, but some of the tools that you use with it are only active while you're observing. So unfortunately, I have to be here live with you guys to learn it. So that's not fun. So for instance, this Atlas idea. Let's get this started. Leo 1, it's called. What is Leo 1? Is it, yeah, a galaxy, I guess. A dwarf elliptical.
Viewing Leo.
Ray, thanks for being a good sport about it, because honestly, unless you're live with the scope at night, there are several tools that you can't figure out how to use on this SkyTools 4. And I've talked with the developer about it saying, can we not just have a way to turn this off or something so we can, but he's insistent on no, he wants to, he wants it to be able to live sort these objects, but I'd love to find a way to turn it off, the live sorting, and to be able to set up like a simulated mode. Anyway, I'm still trying to learn it. Boy, get a load of that look. What in the world? Boy, let's see if we can get this atlas to work. Interactive atlas. Oh, there it goes. Okay, so this field of view, are you seeing that? No, you're not seeing that yet. This field of view here is about the width of the RASA frame. Yeah, so it should be matched now. So that star is Regulus. And then the splotch out here that should appear is Leo 1. I wonder if we're just starting to see something very, very faint there. Yeah, I believe we are. It's so faint though after 100 seconds. 95,000 light years away. I don't see the plane. Maybe it was it while we were slewing? Is that what we saw? I don't know. I missed it. So Robert's living in a river. Where is that again, Robert? I missed, oh, here we go. Santa Cruz, California, too cloudy for astronomy. You do EAA with RASA 8. Well, it's good to have you here, Robert. We started with RASA 8, so all of our early videos are with a RASA 8. So back to this interactive atlas that we're trying to learn how to use. Let's see, where can I put this so you guys can see this? Guess down here. Yeah, there we go. It's not bad. By the way, these little dials up here, this is the temperature, 35.6 degrees Fahrenheit. This is humidity, 86% humidity. So the dew point is 31.8. So this shows the power going out to the dew heater. And I've got it on automatic. It automatically recommends, but you can see it's got a lot of dew action going on. It's set on 8 as a recommended high. And every time the dew heater flashes on, look at the way this current vacillates. Up here, there's a little reading that shows whenever it flashes on and off. And see how this voltage takes a hit every time the dew heater comes on. That dew heater is out there on the end of the scope. Right here. It's a little black, I guess you can see it right there, can't you? Yeah. There's a little black ring around the scope right in front of the dew shield. And that ring is what's heating up. When you see that, when you see the voltage fluctuate, it's because the dew heater has come on. And so the normal voltage is 13.6, but when the dew heater comes on, it takes a 1 volt hit. Fascinating, huh? Okay, back to the atlas. There's Regulus, and I think here will be that splotch, but we're not seeing much of it yet, are we? This is so dim. So faint. Now we're starting to see it. Let's zoom in to about 100%. See that right there, that little faint splotch? That must be Leo 1. It's object 158. Six decades ago, while scanning a Palomar sky survey plate of the area around the brilliant Regulus in Leo, the Lion, astronomers Robert Harrington and A.G. Wilson noticed a faint blur of light, just 1/3 degree north of the star. Wow. That's crazy that we're seeing that glow. And they just discovered it 6 decades ago. They may have thought at first that the glow was just an internal lens flare caused by stray starlight, but it soon became apparent that they had discovered something very real. We know they're fine today as Leo 1, one of the many dim dwarf galaxies orbiting the Milky Way. Leo 1 has a total mass equivalent to only about 20 million solar masses. That's a drop in the galactic bucket compared to the Milky Way, which is comparable to about 600 million solar masses. Dwarf spheroidal dwarf spheroidal galaxies are something of an enigma. Like elliptical galaxies, they show very little evidence of nebulosity or star formation. As with many dwarf galaxies, the stars in Leo 1 contain a very small proportion of heavy elements. That is, elements heavier than hydrogen and helium. That tells us that the stars are very old, since heavier elements are in abundance in young stars. Dwarf galaxies do, however, contain unusually high amounts of dark matter. Wow. Indeed, pound for pound, dwarf spheroidal galaxies have more dark matter than any other type of galaxy in the universe. It's like we're looking into the twilight zone here. Wow. Ray says I can just see it. Wow. This was just discovered 60 years ago. Until 60 years ago, it was hiding there like a pirate ship. Hiding all this time. It eluded Herschel. Studies conducted by Yaroslav Klementovsky of the Nicolaus Copernicus Astronomical Center in Warsaw, Poland, and colleagues suggest that dwarf spheroidal galaxies begin life embedded in halos of dark matter. Over time, the dwarf galaxies orbit around and pass near or through the larger galaxies to which they are gravitationally bound. During each close passage, the dwarfs are stripped of some of their original mass, including star-forming nebulosity. While these kamikaze maneuvers have stripped away the clouds of interstellar matter, the dark matter halo appears to remain largely unaffected. There are two dwarf spheroidal galaxies within the constellation of Leo, appropriately dubbed Leo 1 and Leo 2. Let's take them in order. Finding Leo 1 is no problem at all. Simply point toward Regulus and look 20 arc minutes due north. What's that? You don't see it? I'm not surprised. Although Leo 1 shines at an integrated magnitude of 11, its surface brightness is closer to 15th magnitude. That depressing number, coupled with the blinding glare from Regulus, is enough to hide Leo 1 from view. In fact, it did for all the classical observers such as Messier, Messiaen, and the Herschels. Spotting Leo 1 successfully takes a little planning. First, switch to a high enough magnification so that Regulus can be moved out of the field. Look, that's what we just did. Kind of like intuitively. Avoid the temptation to use too high a power, however, since the galaxy's soft glow is easily dispersed into the background. Leo 1 spans about 10 arc minutes, so its span appears to extend about a quarter of the way back toward Regulus. And he talks about using one eye to look at Regulus and then keeping the other covered with an eye patch. And then once you get Regulus out of the view, lifting the eye patch. Boy, EAA rocks. We're not having any trouble. He says there's a small spiral galaxy just 15 arc minutes to the west. A small spiral galaxy, 15 arc minutes to the west. Do you think it's that? He doesn't have Leo 1 marked. Robin Glover doesn't have it marked. There's that IC591. Let's zoom in on it. Boy, you can even see it there, can't you? With Regulus as bright as can be, you can still just make out that smudge. Kevin, good to have you on board from LA. Kevin can even see Leo 1 on an iPhone 11. Ray's wanting us to make 30 to 45 second stacks. Ray, you always want me to increase my time exposures. But what I don't understand is if we're showing end-to-end stacks of 20 seconds, doesn't that equal out the same as a 30-second time exposure? No? Anyway, let's drop out the... there's IC591. And here's Leo 1. And there's Regulus. Wow, so it was hiding in the shadow of Regulus. What an interesting phenomenon. It really looks like a grainy patch of sky, doesn't it? You can see why Herschel missed it. Okay, let's do what Ray says. Let's go up here and change this to 30-second subs. Or 45 even. This is 50 degrees altitude. Can we see where this is in the night sky? How would we do that? Let's figure this out. Maybe change this to overhead sky or naked eye. Let's try overhead sky. Oh my goodness, look at that. So that's not as helpful, is it? Let's change this to naked eye. Okay, so that's probably what we need. So we're looking southeast, and there's east. So between east and southeast, and then we're up 50 degrees. So it's right at the feet of Leo the Lion. Now I wonder if I can, oh, there's Sirius. I wonder if I can zoom in on this. Touchy. There we go. So that's Coma Berenices. This is Virgo, and there's Corvus the Crow crater. This little blue line here, that's supposed to be the horizon. I did get a horizon programmed in. They don't do, this one doesn't do the photorealistic. So Ray says you can see the small galaxy just above. And Ken says more detail or more blur. Ray says astrophotography stellarium. Yeah. Okay, so now let's switch back to the Atlas. It's I kind of like it. So there's IC591. Up here is that IC591. Strange kind of galaxy, isn't it? Dwarf spheroidal. Dwarf spheroidal. Leo 1. Okay, this just looked like a haze or background glow, but at least
Telescope position synchronized.
At least we could see it. It's supposed to have a bunch of dark matter in it. No wonder it's not as bright. Ha ha. I don't know if that 45-second exposure is helping us or not. I mean, we can now make out a little more of the patchiness of it though, can't we? See how it looks patchier? I guess that's good. Look how there are faint patchiness. At this point, we would know it's not just sky like pollution, light pollution. Let's go look at it in something like a Hubble view. This is Leo 1. Leopard. Leo 1. Galaxy. There we go. Oh, Wow. I don't feel so bad. Look at that. Wonder what captured this, because they're not seeing any more than what we're seeing. Which scope was this? Can we tell? Who took this picture? Metadata. Doesn't say a lot about it. Antler Komonswiki. So that's why this is not like any kind of big observatory picture. This must just be an amateur, because this is what we're seeing. Well, obviously, it's our first time to see Leo 1. Pretty fascinating, huh? Ken, thanks for the encouragement. Dwarf spheroidal sounds like medical terminology. I agree. What a word. Ray says looks brighter. All right. I guess we could take a picture of this. Okay. Let's close this atlas view. Close out the log entry. The next target is ACO 1060. So that's Abell. Remember, that's a galaxy cluster.
The telescope is slewing.
134, object number 134. Abell Galaxy Cluster.
Viewing ACO 1060.
Abell Galaxy Cluster 1060. Abell 1060.
Viewing ACO 1060.
I have a hard time remembering, or I had a hard time remembering at first, that ACO was the abbreviation for Abell because there was already another catalog named Abell. Entry number 1060 in the Abell Galaxy Cluster, AGC. That must be another abbreviation for Abell. Listing forms our Large Scope Challenge 134. Also known as Hydra 1, AGC 1060 covers nearly 3 degrees of our southern spring sky. So right now it's up about, only 15 degrees altitude. More than 100 individual galaxies. Ray, you're the one that taught me that we have to reset the display histogram. Who ever thought that live streaming via EAA would be a way that you would teach the guy who's live streaming? But that's exactly what happened. Ray helped. I would have never ever thought of trying to reset that display histogram up there. Robin Glover, you're a genius. Thank you so much for introducing plate solving built right into SharpCap. Control-Shift-A. Okay, so there's ACO1060. Each one of those is a galaxy. This is a star. Hipparchus 51979 is a star. Magnitude 4.8. But oh, that's a star. Except for these two stars and crosshairs, everything with the circles is a galaxy. Yeah, look at this one. Spiral here. These look like ellipticals. This is ACO1060. Covers 3 degrees, 14 NGC numbers, an IC one, shows how to find it. Wow. Talks about each one, but mainly what he says is they're just little blobs, little faint glows. This is Harrington's list of all these galaxies in this one cluster. It's a huge list, right? And it gives you a sketch to help you find them all. Take a look at the sketch. If you didn't have deep sky image annotation, that would be what we would have to use to find them all. Now, thanks to Robin Glover, we just go Control-Shift-A. Bam. And then we've got our own overlay. That's a team sport Ray was talking about when he taught me to use the display histogram. Let's see if we can bump some of this, some of these mids up and brighten up those galaxies a little bit. Okay, I'm going to create a log entry here. So he says at least 100 individual galaxies. Wow. "100 galaxies in a cluster." Wow. So much mass. You know, now we know why the Starship Enterprise had so many years of missions, right? So much to explore. And then there's also Stargate. No wonder they had so many places to go. What, 10 seasons on Stargate? Isn't that a cool little spiral there? It's like got a big core right in the middle. Look at this material being flung out from this. This is Abell 1060. Sorry for the blinding. Abell 1060 Hydra cluster. Hail Hydra. This is I wish they'd put underneath it who took the picture. This got to be Hubble, huh? Oh my goodness, look at that. I don't know if you can see very many things that are not galaxies. So many of those. Look, here's that spiral we were probably seeing. Man. Oh my goodness. Think of all the stars. It's just breathtaking, isn't it? It's breathtaking. Okay, I admit, this is better than our RASA. Whoever took this, somebody tell me, where does it say, Tiffany says, aye, Captain. Never-ending universe. Where does it say who took this? Information from its, this is a file from Wikimedia. I wish they would just put right underneath it, this was taken at Palomar, you know, or whatever. Legacy Surveys, Perimeter Institute, NERSC. Anyway, there you have it. It's beautiful, huh? And there's the live view. That's 100%. Looks like our focus is snuck out a little bit out of focus. Temperature dropped. See, it's 34.9, so it did drop 2 degrees. Okay, ready to move on? Oh, let's go to the Coma Cluster.
The telescope is slewing. Viewing Coma Cluster.
Kevin says, when I'm lucky enough to capture a very busy background, he likes to play, how many galaxies can you find? Yes, Tiffany, that was the exact area we were looking at, except that was the night sky survey from some observatory with 6 letters in their name. Ray says thousands and thousands. Okay, so the Coma Cluster is object number 164. Well, that's in the Monster Scope challenges. As challenging as Abell 1363 is, it pales against its big brother, the Coma Galaxy Cluster AGC 1656. Spanning an area more than twice the size of the Leo cluster and holding more than 800 galaxies, brighter than photographic magnitude 16.5. AGC 1656 is a real galactic forest that will take great patience to make our way through. Can already see some. Tiny, tiny, tiny little things, but they're already there. Control Shift A. Oh, look at all of us. My goodness. It just makes you think how big this place is, doesn't it? Every one of those could be the same size as the Milky Way. Oh, Chris, that's very kind of you to hit the like button. It does help others find our channels, so thanks so much. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23, 24, 25, 26, 27, 28, 29, 30, 31. I'm going to take it off because it's so latent. But let's zoom in here in the middle. There's so much latency when the deep sky image annotation is on. Now let's put it back on there. That's just what I figured. If you zoom in on a section, then there are even more in that section. So here are another 25, just in this really tight zoom. Every one of these could be the same size as the Milky Way, meaning there could be millions of stars in each of those galaxies. Millions. It's kind of just too much for me to contemplate. It's just, these galaxy clusters are just beyond my ability to imagine. This is at 31 degrees up. Which one was it? The naked sky one that showed us? Yeah. So we're at 31 degrees up above the eastern horizon, between east, it's east-northeast. So here's that Boötes that looks like a kite. This is the Little Dipper. Here's the Big Dipper. So if you kind of follow the handle through the cup of the Little Dipper and veer down a little bit, you'll see the Coma Cluster right where we are. And it's from Coma Berenices. That's where it gets its name. It's not like it's having a coma in a hospital. Ray says, it is mind-blowing to think about how big the universe is. Now let's switch this to this interactive atlas view. So in this case, with the Coma Cluster, first it just marks it with a circle. And then I bet when we zoom in, it starts beginning to show you every one of these galaxies. And the great thing about SkyTools 4 is that every one of these is identified, regardless of how small it is. Every single star is identified. So I'm really liking this atlas. So we can do a deep dive. And every one of these has a name. And when you hover over it, down on the lower left-hand side, like that's IC3998. This one is LEDA 126781. And that one is PGC 44656. So every one of these has a name. Now that's a star. It's J125941.4 plus 280008. Every single star has a name. And I kind of like that idea. I shared with you guys last time. I kind of like the idea of being able to see every star's name, because I get a kick out of it knowing that God puts the stars all there, and it says he calls them by name. He calls them one by one. And I love the idea we can sort of call each of the stars one by one. Someone has a lot of patience to put that together. Yes, that's for sure. And Ray, what I like about SkyTools is it is a curated background database so that it's all been meshed together, whereas every other targeting software I can find, when you inlay a new catalog, it starts a new version of those objects, but they're not matched together. When an object is found in multiple catalogs, they're not intercorrelated. And what Greg has done with SkyTools 4 is he's painstakingly correlated all those objects across all those catalogs, so you don't get this duplication. I remember the first time I brought in the Herschel objects, I was going back to some of the same things. Remember that? Some of you were with me. I think Stu, you were with us. And Stu would say, we've already looked at this. And that's because we looked at it under Caldwell, but it wasn't recognizing that we looked at it, because now it had a new name in the Herschel list. It had a Herschel identification. So what Greg has done in this SkyTools 4 is he's correlated the catalogs, so now they'll be marked as observed in multiple catalogs across all of them. So I like that. All right, so let's close that atlas, and let's remove the steep sky image annotation and just look at live views of some of those. This is an amazing collection of 100 plus galaxies strewn across.
Telescope position synchronized.
A field of view that is fairly wide, relatively speaking. But these galaxies are fairly tiny. Last time I was here was a night you had thousands of people watching meteor shower. We're glad you came back, Chris. Yeah, Ray is remembering that. Ray says move the blacks to the left a little. So in other words, you want the sky to be brighter. Yeah, there you go. Deep sky image annotation. Portrays this area as a near endless sort of gravel driveway of galaxies. It's really beautiful. Now at this point, the guy's software tells us that there's nothing else fit to look at. But that's just because it thinks we can't see them. And I really regret that, because I think we can see some of these things if we go. So let's try it. We've still got 8 minutes before we close out. So let's close out our sequence and go back to next target. Let's go to Palomar 4, whatever that is.
The telescope is slewing.
Palomar 4, object number 161.
Viewing Palomar 4.
When you think of deep sky objects in Ursa Major, you probably don't think of globular clusters. Galaxies, sure. Planetary nebulae, well, there's the Owl Nebula. But globular clusters? Probably not. Palomar 4. Well, guess what? There's actually a renegade globular cluster within the Great Bear.
Viewing Palomar 4.
Today, we know it as Palomar 4, the fourth entry in the list of 15 challenging globular clusters discovered on the plates of the Palomar Sky Survey 60 years ago. This particular globular was discovered by Edwin Hubble in 1949 and confirmed a year later by A.G. Wilson. Based on early observations, Palomar 4 was initially misclassified as a dwarf spherical galaxy, in part because of its remote distance. Palomar 4 is estimated to be 356,000 light years away from the Sun. That's farther away than the two Magellanic Cloud satellite galaxies. More recent studies, however, prove that Palomar 4 is indeed a member of the Milky Way's family of globular clusters, albeit the most secluded, save for ARP Medone 1 in the southern constellation Horologium. Tells you how to find it. The cluster's far-flung distance, coupled with its inherently weak stellar concentration, conspires to dilute it to nothing more than a very faint glow measuring just an arc minute or so across. From my suburban backyard observatory, my 18-inch reflector revealed only the faintest hint of the cluster, and then only fleetingly, with averted vision. That's with his 18-inch reflector. Okay, pressure's on now, folks. If searching for Palomar globulars is your thing, have at it, basically. Pressure's on. Can we find Palomar 4? I believe we already see it. He doesn't have it marked. It's too small and too faint. Is not it right there? Here comes the Atlas. Let's see. I think that's it right there. So here are these two stars are these two stars. See that close one there and that one in the middle? So that's this array. Right there it is. We saw it in 3 minutes. Guys, EAA is the ticket. He couldn't even see this in his 18-inch. I like this new Atlas. Look how clear that is. Yeah, that's that star there and that star there, which is that one and that one. And then you had that little star there and that little star there. Let's zoom in a little bit more. Can I move that around? I can. I can grab hold of it. Wow, that's nice. You can just drag it. So look, he not only shows this star, but on this atlas, he names it. It's GSC 01984-1554. That star right there has a name. That star has a name. It's GSC 01984-1301. So that star is there. And that Palomar 4 is right here. Just discovered 60 years ago, and that was at Palomar Observatory. Just, out there between LA and San Diego. Wow. There's a little galaxy right here at the edge of the globular. You know what else? We can even see the galaxy. Right here is Leda 185-1492. Leda 185-1492. Wonder what magnitude that is. Leda 185-1492 galaxy. Not even in Google.
Leda 185-1492 is an intermediate galaxy in Ursa Major. It is magnitude 18.3, with an apparent size of 20 by 8 arcseconds. It is 1,400 light-years in diameter.
See, that's just the berries. To be able to click on that and get those details like that, just instant. It tells the position angle. .3 magnitude. No wonder we saw it. Man. Well, guys, it's 12:30. I know Ray says, I knew you could do it. Did you auto stretch? Yes, I think so. Thank you, Stu, for being on board. Palomar 4. It is faint. I mean, we'll give you that. But it also is there. Thanks for being a part of this. Thanks to God for making these things putting a globular cluster 300 and some, how many? 356,000 light years away. God knows all these stars one by one, and we can now name them with a name that we've given them here on Earth to kind of celebrate that. I've never seen Palomar 4 before, but now you have. After 7 minutes, pretty clear right here. Thanks for being a part of this. Ray, Tiffany, Stu, Kevin, and to you who have tuned in also in the recording. Thanks for being a part of this. This community is a lot of fun for me. It means I'm not doing this by myself. We're all kind of doing this as a team. That's fun. I'm grateful that we've been able to see these things tonight, such distances, such amazing number of stars that we saw. And we're continuing to work our way through Cosmic Challenge. I guess we have around 30 targets left, something like that. We'll keep working through them. And I'm working on a new book now, getting all of them in. It's called 1001 Celestial Wonders to See Before You Die. Kind of a funny title. 1001 Celestial Wonders to See Before You Die. And I've got about 500 of them in so far. And they're all going to be beautiful as well. So we have 1,001 to go. But many of these are objects we've already seen. However, there are a number of objects we haven't. So I have plenty left to do. I hope you'll click subscribe if you like content like this, and that way you'll get the notices. You can go to emeraldhillskies.com and sign up for the email list there. You also get an email that way when we're going to be on. You can look there and see a little bit more about what we do at emeraldhillskies.com. But here in the YouTube channel, you can click the bell and click subscribe, and that lets you know when we're on YouTube live. And some of you came, I know, tonight because of that. This is a lot of fun. We appreciate you guys. We'll try to be here any clear night. If Monday's clear, I bet I'll be back. And I think Monday's going to be clear again. Whenever you can make it, stop in. And we'll look forward to seeing you guys again just as soon as you can get back. God bless. Good night. Thanks again, Tiffany and everybody.